All right, so you never know if you're going to get such a lovely introduction. So I always include this slide. This is me. These are some of the snakes I've conned talented designers into making, some of my proudest achievements. This is Piper, my latest acquisition. I do have a couple Pepper, sorry, confused. Man, all right. So this is Pepper for Peps. And she is the Python mascot on Heroku, which is where I work. I'm the Python platform maintainer. So if you deploy to Heroku and you have compliments or complaints, I want to hear. All right, this slide looks a lot like what we just saw. Who was in the keynote just now? All right, let's just take a collective deep breath in and deep breath out. One more time, deep breath in, and deep breath out. Thank you, that was entirely for me. So, PursuedPyBear. I came across this, I'm not a core maintainer. I've submitted one issue while working on this talk, but I came to this because some of my first jobs in tech were teaching kids how to program using video games. I've worked in the Minecraft code base. I've worked in kind of small fun with small projects with Raspberry Pis and things like that. And so this is a passion area for me. I'm always kind of looking for what's going on. How do I continue this kind of hobby? So as developers, what this reminds me is that we have superpowers. We connect people across the globe. We bring supermarkets and shops into people's living rooms. They don't have to leave their house if they don't want to get that pair of shoes. We make that possible at scales that are unprecedented. That's really cool. We impact every aspect of society at this point. We have a lot of power there. And you have one more superpower. Making video games. If you know Python, you can pick this up. We all will silly walk over to the cafeteria and we can get some games started today. You can have something that looks pretty cool. And I think that's really powerful. Now, the trick, who has actually done a little bit of video game programming on any level? Okay, cool. So there's graphics can be a little wonky. They're a little special. Sometimes takes a little bit of trigonometry or geometry knowledge to kind of get in there, right? But the thing that I like about PPB is that you can just write idiomatic Python. You define classes and you define functions and you run your cycle. You run your game and there it is. I think this slide speaks for itself. So from PPB's docs, at its core, it provides a number of features. It's an API for making video games. It's a pluggable subsystem architecture, and when adding new features, it's as simple as subclassing and extending. It's aimed, as Piper already mentioned this, but it's aimed at teachers, educators, and beginning programmers. And anyone who wants a game, in my opinion, doesn't want to spend the next 10 weeks on it. You can, but you can also just spend the next hour and have something that you feel kind of good about, which I think is empowering. I've also, in my experience, found it really flexible and really fun to play with. So, yeah. So go check out the docs too. All right, who's behind PPB? Hint, she's over there. There's a couple other contributors as well. Moshe is here. He's done a little bit of work with Twisted. Here's the contributors graph. Lots of people have made this happen. This is a really cool example of a early stage open source project that you can use for examples on how do they manage issues, how do they document. From that perspective, it's been really enlightening as well, just to kind of see how this open source project has evolved. So thank y'all. Most importantly, not me. I'm an interested extra party. So this is not, I have not made this library. Just a fan. Okay. Some game terminology, although lots of us have gaming experience, so we can jump over this a little bit. A basic game can be boiled down to a game loop. You have events, you have listeners, and they impact your environment, your NPCs, and your game character. This is a simplified version of what you see kind of brought up in different systems. And the important, and this actually happens on, if you're familiar with developing any kind of interactive JavaScript web pages or any kind of interactive GUI, you have probably a similar workflow, right? The only way to maintain that reactivity at that level is sometimes to have that game loop always listening, always watching. We have this in PPB as well. But your workflow is going to be a little bit simplified. You define classes, you define your scene, and then you run your game. And these are the steps you're going to find yourself stepping through each time you begin your PPB games. All right. A lot of this is at the library, or at the open source repo here. I went through this and found it really enlightening for just the intro level. So we're going to look at very basic kind of hello game, and then I'm going to demo a very rough game that I've been working on that I have enjoyed quite a bit, learning some of the mechanics for. So the basics. This is where we start every file. You import and you run. This is it. If you're curious what this shows us, enter. All right. See here, here's the file that we just specified. Now, if I do, ooh, it's a window. Thank you. This feels silly, but just getting to this point in other frameworks can be, right? I see some heads nodding like this is just getting here. The fact that this was 2 lines and one of them was the import is a great experience just out of the gate. Whoop. There you go. Okay. Next up. First thing, you need a player character. So we're going to define a player class, and we're going to import from base sprite. There have been some updates to the base sprite class, so I might be a little bit out of date here, but I'm instantiating with base sprite, which just provides some really basic, like, this is a thing in your game. It might do some stuff. Very, very simple. And then I set up my scene, and I add my player to it. So this is, ta-da, same code. Ooh, yeah. I'll talk about the assets in a little bit, but I wanted to show what it looks like before you have game assets or files or PNGs that you've drawn. As you're developing it. So you have a visual representation of what your player character, rough size, where it will be on the screen. You don't need to actually have your art asset files before you start working on your game mechanics, which I found really empowering, just to start like playing with it. So. All right, but this doesn't do anything yet. So we're going to take that, this is obviously a duck. And something I found, if you're ever looking to make some really quick assets, Google Draw is great. And if you're ever looking to make animations, we'll get to animations in a little bit, but really quick tip for these assets is keep it still, move a tiny thing, download the next file. Move it again, download the next file. Quick hack for Google Draw. Anyway. So we want our player to do some stuff, right? So we've added a OnUpdate class, and this function signature is important here. You're always going to provide the self, an update event, and a signal to this. And you can see here, we're going to take the position, and we're going to add the velocity plus the update event plus time delta. Now, something that actually took me by surprise, I'm used to 0, 0 being top left of the screen. I wanted to cover this. This is a little bit different. Oriented. These are the jokes, folks. So here we have, I apologize in advance for any painful geometry memories bubbling up for anyone, but the vector in PPB does not start at that top right. We can see our coordinate plane here. These are the coordinates you'd be entering in to achieve these directions. So you might be used to 0, 0. This is not our 0, 0. This is our 0, 0. So you put in vector 0, 0. That will come up in the center of that window. You say 0, 1y, 0, negative 1y, negative 1x, plus 1x, just to orient. I thought that was cool because I hate the top left 0, 0. I hate it with a passion, and I like this a lot better. Okay, now, games run on a game loop, right? Usually they use a publisher system model and a listener system model. Here, any class you define, because we're using data classes behind the scene for the eventing system, it's in scope. This player has all of the events that could be relevant to them because it is in their scope. So you don't have to define any extra listeners. They're available to you right away. And that is that update event, which is also a nicety that kind of smooths over something that has to be re-implemented almost every game, depending on what framework you're working with. All right, let's see what this does. All right, so we are on to version 1. All right, so we have the OnUpdate. We're going to move a little bit. So we want to do, always save your files. Right. Woo! It's moving. Oh, it's gone. All right, so that is version 1 of this. Now, that's okay. It does a thing, not a very interesting thing. So the other cool thing about how classes are used in PursuedPyBear is that these attributes are used directly for your player's attributes. So you can define the speed, just like this is as easy as it is. Bloop, it's there. We're going to update, instead of velocity, we're going to use position and direction to say, okay, where am I and where am I going next? Where am I thinking about going? And we're going to update our OnUpdate function to now use this new definition. So that'll be, the new position is going to be the direction times the speed times the update event. Okay? Let's do it. So, not this one anymore. We want there's our new functionality. Oh. Shh. Interesting.
The direction. 0, 0.
said that. Boom. Okay. All right. It goes even faster off the screen. So it's not super interesting. We want to be able to control our player. So we import some key codes. This is directly from the Pygame library. If you look at the file about key codes, we're just mapping in a large dictionary, like the Pygame key code for this to our new key. So we can do really nice stuff like this. This is as simple as it is to say left arrow, right arrow. Ah! This is really cool. So now, with these new left and right key codes, we want to expand our functionality to make use of this. So this isn't the full code, we'll look at it in a second, but the important difference is instead of on update, so now we're not just listening to the game tick, the heartbeat of our game loop, now we're actually just waiting for these events to come in, which we're already listening to. We are waiting for a key pressed and a key released. So let's go, which we already have been, but let's. All right, so here we have, you can see at the top, here are our key codes imported, right here. Here's our player, we have direction, position, speed, our key codes here as well. And now you can see the functionality here. We're just catching this event and checking the key event for the key value. We're checking its attribute to see what we got working with. And if this, then that, essentially. This is a good example of how this functionality is broken down and really can be used powerfully to teach kids or beginners with the language how do these if-else statements work? How do attributes work? This really digs into some really important Python fundamentals. So I like it. I can write Python for a game. This is cool. So let's run it. All right, left arrow. Right arrow. Ooh, I'm loving the energy here. We can control our player. This is so exciting. But this isn't all we can do. So, hold on. Oh, shush. Now, this example, again, is taken from the docs, and I'll show you my game in just a second. But I wanted to highlight a couple things. First off, so here's our player. Not too different. Important addition from the last scene, or the last file. We're adding a new key event. We're now looking for the space bar so we can have a projectile. This means that we now need something to target. So we have a target class. This is simply checking if a projectile has reached its same space in the window. So here, we're getting any projectiles available. We're checking the projectile's position. We're checking this target's position. And we're looking if the length is the same as the size of our target. And that means, if that is true, we should remove this target. The projectile class, it's got size, direction, and speed. I wanted mine fast, so this is faster than the documentation. But on update, this is really cool. It kind of normalizes the direction. So if you're moving side to side, it has some of that cool, like, going on. And then in our scene setup function, we're adding our player still. But now, for a specific range, this allows us to add targets at a set 5 targets at a set distance across the top of the screen. So let's run main. All right, left, right, spacebar, spacebar. Woo. Whoop. All right. PursuedPyBear also has functionality for loading screens for more complex things that I have done or am about to show you here, but I found that just the pluggable architecture definitely holds through, so it's a lot of fun. But, so here is the final. There's a lot going on here. We can dig into this. Oh yeah, you all ready? Okay, there's a lot of code going on here. We can step through this together afterwards. But to run this, may I introduce for the very first time Oh no, the sound isn't coming through. Ah. I got him. Thank you all. I think we're just about at time, so if you have any questions, any comments, I'm going to walk that way to where the food was, and you can catch me there. I also have PursuedPyBear stickers if you're interested. So, woo!